Let's see the philosophy of green chemistry. So, green chemistry has been adopted by many companies and passed into national and international laws. There's 12 principles to this philosophy that emphasize the benefits of non-hazardous chemicals and solvents, the efficient use of energy and reactants, and the reduction of waste substances. Now, the aim of green chemistry is to reduce environmental impact of chemical processes by minimizing the use or production of hazardous chemicals. So this is done by a number of ways. So we have solvent-free reactions, a reaction that do not use any solvent. If you don't use any solvent, you won't have solvent waste. Renewable starting materials, mild reaction conditions, so you are carrying out the reaction at lower temperatures, lower pressures, and also the use of byproducts used during the synthesis. So any byproduct that is formed during the reaction is reused in the synthesis. One example is during the synthesis of oseltamivir, the Tamiflu medication. Now, oseltamivir requires shikimic acid. Shikimic acid is normally extracted from the pods of star anise. This is star anise, it's a spice, and star anise has a limited worldwide supply. In 2005, there was a temporary shortage of star anise worldwide, and this shortage was caused because of the use of shikimic acid in the production of oseltamivir. Moreover, in 2009, when there was a swine flu outbreak, there was also an increase in production of oseltamivir, so they needed even more star anise. So there was another shortage of star anise in the world market. So problem with the production of oseltamivir is that it is a complex 10-step process. And also, the time required for its production is around 6 to 8 months. Plus, 30 kilograms of star anise will produce only 1 kilogram of shikimic acid, which means that there has to be another way of getting shikimic acid for the manufacture of oseltamivir other than from the pods of star anise. So, modern biosynthesis has allowed shikimic acid to be produced on an industrial scale by genetically modifying E. coli bacteria to prevent any shortage of oseltamivir, which means that the E. coli bacteria will now be producing shikimic acid. Another method to obtain shikimic acid is to extract it from pine needles. Normally, pine needles are used to make essential oils. They are also used as home remedies, but these can be collected and you can obtain shikimic acid from it, reducing the stress of obtaining shikimic acid from star anise pods. The use of natural products in synthesis leads to ecological issues like extinction of plant species and rising food prices. This is why we tend to avoid the synthesis of medicines from plant species, because you have the problem of extinction and the problem of rising food prices. So with this, we finish topic D6. You can try out the questions